Welcome from all across the globe. My name is Edward Ianel, and today we will be taking a look at Lens, the Kubernetes platform. It is a desktop application that you can use to manage and monitor multiple Kubernetes clusters, regardless of the distro. As long as it's a certified Kubernetes cluster, Lens will work. A little bit about myself. We don't really need to jump into this slide too much since we just had this reviewed by our host. So thank you so much. So whenever I like to talk about Lens, the Kubernetes platform, first I like to take a look at the cloud native landscape and how complex the entire cloud native landscape is. Whether you're working with Kubernetes or any other cloud native technologies, DevOps practitioners, DevOps engineers, developers, and so forth have a lot of complexity when it comes to the overwhelming amount of technologies and tools. So this is where Lens begins to come in. Lens identified, or we, Team Lens, identified all of the challenges that Kubernetes users may face when working with Kubernetes at scale. They have to leverage multiple different documentation. They have to leverage different tools, different command lines from kubectl, kubectl, kubecontrol, whichever variation of the terminology you like to use, all the way to leveraging YAML. And then you use different Kubernetes dashboards. You have a cloud console, you have your Helm CLI and so forth. So you're leveraging multiple different tools and technologies when working with Kubernetes. So usually organizations, developers, site reliability engineers may be having some challenges, as well as not seeing the return on investment they would like to see when working with Kubernetes. This is where Lens comes in. Lens is a desktop application built to allow you to achieve full situational awareness of everything that's happening within your Kubernetes cluster, again, regardless of the distro. It significantly increases productivity as well as time to market for your applications and increases your return on investment. But I like to think about Lens more from an end user standpoint. That's very much specific to decision makers. But from an end user standpoint, Lens really does allow you to eliminate Kubernetes complexity. And that's some of the things we'll be taking a look at today. I like to throw some stats up always in our presentations where Lens currently is. So again, Lens is based off of an open source project called Open Lens that we here at Mirantis have developed, contributed, and maintained. And we have seen this project grow significantly. Lens desktop application currently has over 700,000 users. Some of these numbers are a bit outdated, as we can see. Last updated was June 21st. But we can see that we have roughly 650 to 700,000 users today, and we have over 18,000 GitHub Stargazes on our open source project, Open Lens. So how is value measured with Lens? It's quite simple and straightforward. It's going to really accelerate your Kubernetes time to value by increasing your adoption speed of Kubernetes. So onboarding new users to Kubernetes, to your platform, or if you're somebody that is completely new to Kubernetes, being able to understand how Kubernetes works from the objects, the resources, your deployments, your workload, services, networks, and so forth. So many different components and resources within Kubernetes. Lens is really going to streamline that learning experience for you. Then we also solve Kubernetes complexity. The neat thing behind Lens is it begins to consolidate multiple tools that you would leverage when working with Kubernetes. This is one of the steps to eliminating Kubernetes complexity. Then, of course, one of our favorite value props that we provide for our end users is we do increase the productivity when working with Kubernetes. So on average, each developer per week is saving 8 hours out of their week using Lens. So roughly an hour and a half a day or 8 hours per week. So where does Lens fit in a developer's life cycle and in their inner development workflow? Well, Lens actually falls in to the end of their workflow compared to operators where Lens is going to be at the beginning. So developers generally need to write some proprietary code. They need to use some type of technology like Git, Docker, and so forth. Then they go into that CI/CD process that we all may be very much familiar with, right? Being able to push their applications on top of their infrastructure, specifically Kubernetes. And then this is where Lens comes in. Lens is going to come in from the troubleshooting and debugging and being able to understand how your pods are performing, as well as the application or the workload on top of Kubernetes. So being able to really get a full situational awareness of how the application is performing, and then leverage the different features within Lens, the terminal, the ability to access logs, and begin your troubleshooting processes. The next one is operations with Lens. So Lens is going to fall into the beginning of the workflow for somebody that's a site reliability engineer or an operator. They want to very much understand the health and the status of their cluster, as well as all of the objects and resources within. They're going to be monitoring real-time events to understand how specific items are performing. And they may want to be taking a look at if there's a drop in the life cycle management to begin troubleshooting, and they can also provide developers with logs dependent on the organization processes. We had a chance to talk about this quite a lot already, but Lens is really going to be for developers and operators that work with Kubernetes on a day-to-day basis that want to achieve full situational awareness without the need of having to write any kubectl. We also have Lens Cloud, which is a centralized offering on top of OpenLens, which is going to be a feature and functionality that allows teams to collaborate when working with Kubernetes. The neat thing behind Lens Cloud is if I have a team of developers that need to access a specific namespace within my Kubernetes cluster, I can actually share the cluster with that team of developers and the namespace without ever giving them access to the kubeconfig file. So I'm able to share access to a Kubernetes cluster remotely, as well as revoke that access as well. So from here, we're actually going to be taking a look at a demo session of Lens 5.5. In this session itself, we'll take a quick look at how you can actually manage and monitor multiple Kubernetes clusters in Lens. So I'm going to navigate to the desktop application. This is Lens. Currently on the left-hand side, I have several different Kubernetes clusters added to my environment. As mentioned, Lens is a desktop application that works with any certified Kubernetes distro, and we are always honoring your role-based access control from your kubeconfig file. Meaning if you don't have the correct permissions, you cannot just upload the file to Lens and begin to perform admin functions to that cluster or environment. So we're always leveraging the role-based access control from your kubeconfig file. Here we can take a look and see that we have 3 different Kubernetes clusters currently added. We have MKE, we have Minikube, we have UCP, and so forth. Clicking into my Mirantis Kubernetes Engine cluster, I can immediately understand how this cluster is performing in the last hour, from the master to the worker node and the CPU and memory as well. I see real-time events here, and we have pods. I can see the entire capacity and so forth. Now, we wanted to talk about managing and monitoring multiple Kubernetes clusters. So to make this quite obvious, I need to run a quick command line to show the API version of this Kubernetes cluster. Here we can see that we're connected to Git version 1.21. That was somewhat of a tongue twister. And I can now navigate to my Minikube cluster and immediately get full situational awareness of everything happening within this Kubernetes cluster. And if I navigate to my terminal, I can actually see that it's always matching to the correct Kubernetes API endpoint. So this allows us to switch from cluster to cluster while always maintaining the correct context of that Kubernetes cluster, ensuring that we're working in the right environment at that given moment. A lot of our users are navigating between production clusters, proof of concept clusters, staging clusters, development clusters, and so forth. And because Lens has this smart console, they're able to actually switch from cluster to cluster while always maintaining that correct context. So within my MKE cluster, I want to take a look at our nodes. I can see the CPU, the memory, and all of the resources of the nodes, as well as a detailed description through a pre-built-in Prometheus plugin that allows us to very much understand how this particular node is performing. On the right-hand side, we can see we have several different admin functions that we can perform. Again, this is based off of your role-based access control from your kubeconfig file. So again, somebody that uploads a kubeconfig file to Lens, but if they don't have the correct access, they will not be able to do this. You can edit this resource, open it, and immediately bring up the YAML to begin debugging if you choose to do so. Well, we're not going to debug any nodes here, that's for sure. Now we're going to navigate from workloads to overview. We'll go to our pods. And here we can actually see every single pod within our Kubernetes environment and the status as well. Now, why is this important? Generally, a developer that's working with Kubernetes that wants to understand how their applications are deployed, the first step is generally to take a look at what is the status of their pods. Whenever you're troubleshooting an application on Kubernetes, you want to take a look at how is your pods performing and what is the status of those pods. So generally speaking, a developer is going to have to write some form of command line, kubectl, pods. And now it's going to give us a message as well as the status of all of our pods. Now navigating back to the UI, we can see all of this information relatively quickly through the graphical user interface without writing any command line. Now let's take this a step deeper. We can see the status has failed. We can see that these pods are pending. The interesting note would be to see actually why is this pod pending. So here in this warning message, we can see that it's failed to pull the image. So it's unable to pull the image due to a specific reason. Generally, if we want to see these warning messages or these messages, we're actually going to have to write additional command line. Now, Lens is going to allow us to do this quickly without having to write any kubectl. For demonstration purposes, describe pod. Let's close this a bit, and we'll grab this pod name. And here we begin to get a list of some of the logs, right, to begin troubleshooting this pod. And yes, we did this through kubectl, but right before that, I demonstrated how you can just leverage Lens to do this very quickly without actually having to write any kubectl. Now navigating back, we can see the state, we can see the reason, and we can also begin to scroll down and see the exact message of why it failed. Now this is done through kubectl. Now the neat thing is, again, not to reiterate myself, we can see this all through Lens. We can view our deployments, our daemon sets, our stateful sets, our replica sets, and so forth. Now, Lens has several other features as well outside of just the full situational awareness and the multi-cluster management that we discussed. Lens also allows you to create and deploy resources directly into your environment if you choose to do so. So somebody that's new to Kubernetes, somebody that works with Kubernetes on all the time can actually go to our resource template, either copy and paste their own YAML, or they can leverage one of these templates to, let's say, deploy an Nginx deployment. I can click create and close. It's going to deploy it. We can navigate to our pods. We can take a look at the ages, and we can begin to see that it's actually pending and creating. So I think many of you are probably beginning to see some of the value Lens provides. But outside of some of the things I discussed, there's many other awesome features as well. You have the ability to deploy Helm charts directly through Lens as well. So you can search through thousands of different repositories, find a Helm chart you like, get a step-by-step guide on how to do it or install it, or you can install it through the click of a button. I'm not necessarily sure what type of Helm chart this is, so I will not download it directly to my Kubernetes Kubernetes Engine cluster, but I can navigate to my Minikube cluster and simply install Cassandra. And this will be deployed directly on top of our environment, as we can see. So now we can view the Helm release. And we get all of the details associated to this release to really achieve, again, some of that full situational awareness, understand what resources were deployed, see the secrets, the services, and so forth. Another neat thing with Lens is the ability to port forward directly into an application without the need of actually having to write any kubectl as well. So I don't think I really have, let's take a look. maybe I can navigate to this cluster and see I can switch to this cluster immediately. I'm working in the correct context. From here, I will click services. Let's see what kind of services we have and what we can port forward directly into. Prometheus. Let's see. And we can see that it did port forward directly into the Prometheus application. So we've gone through several different things here so far. We've gone through multi-cluster management from MKE to Minikube. We've taken a look at our nodes. We're able to understand how all of our workloads are performing at a given moment, as well as being able to understand the specific status of our workloads as well. We took a look at some Helm charts. We took a look at creating resources. The next thing I want to take one last look at is real-time events. I find this extremely useful, regardless of what your job function is or role. Generally, developers are going to be leveraging this more than anybody. But here are real-time events for every single involved object that you can click into, get a clear understanding of the name, the namespace, the message, why it happened, the involved object, and begin troubleshooting from here as well. So this is Lens, the desktop application, all of these features we mentioned. Now on the top right-hand side, we also have Lens Cloud, or this is a feature that I call Lens Spaces. Lens Spaces, and we touched on this slightly in the presentation, allows us to very easily share a Kubernetes cluster with our colleagues without ever exposing the kubeconfig file. I have no colleagues here with me today, but the neat thing behind this is I can actually add my Minikube cluster to a shared space, create a shareable link, and share that link with a team of developers. From there, I can ensure that our role-based access control is only that our role-based access control is only allowing our developers to see a specific namespace. From there, they begin troubleshooting the deployments or the workloads on top of that namespace. So the use cases are actually quite large. Outside of development, you can even use them for support organizations that want to take a look at something within your Kubernetes cluster, your environment, and so forth. So the possibilities are quite endless when it comes to Lens Spaces and allowing people to get access to a Kubernetes cluster without ever exposing the kubeconfig file. So I do want to ensure that we also open up for some questions. There's various different features that we could go over as well, but I wanted to give a high-level overview of the product and how you can manage multiple Kubernetes clusters while maintaining the correct context and reviewing all of your workloads, the pods, and so forth within your environment. Now, again, I would love to open it up to see if there's any questions that I can answer for the audience.